Hi, I'm Friedrich, and I'm here to look at the question of whether the Earth is round, flat, a triangle, an isosceles, or a dome. Well, all things serious here. I do have some customers and friends that actually believe the Earth is flat, and this is not something that most people have ever questioned, whether it's a globe or a flat Earth. And to me it really hasn't mattered that much, but I have found myself just assuming that the Earth is round and so forth, just like most people, and you'll see my children have assumed that as well. So I want to look at this not very critically and not with absolute precision and all that, but I want to look at this issue from an average man's perspective, or I want to look at it more casually, let's say. I have a friend of mine who believes in this, and I said to him, well, really, what can I do to verify this one way or another? What is acceptable besides trying to get all these do these things that are really beyond my reach? Having meters, specialized meters that I have to learn how they work and how to be able to evaluate them, or to make very expensive trips in private airlines or airplanes flying over Antarctica and whatever else. These are things that are really beyond my capabilities and my reach. So what can we do? What are some very simple things that can be done to look at this issue one way or another? Now, obviously there's several things involved with various models of whether the Earth is flat. One of them pertaining to the sun, and I'll get into that a little bit later. I've already shot a lot of video, and it hasn't turned out exactly as the way I wanted it to, because I wanted to film distances, and the intense heat right now has created the smog in this area. I can't see as far as I wanted to, but I think we can see enough, and this video will add a number of important observations that should add value to this video beyond merely the things that I'm saying right now. So I wanted to find out with my friend, what can I do to look at this issue really simply? And one of the things was, okay, well, over water we can look at the horizon and we can measure it. So my goal was to rent a boat yesterday and drive away from Toronto Harbor at various speed distance over time. Now, we never got around to renting the boat because I realized the visibility wasn't very good. So then I thought, well, I can just do that all on land. And so I did do that. I went from 30 miles, 35 miles, 20 miles, 15 to 17 miles, 10 miles away, just to see it right at the water level. Because if there's a curvature of the Earth, right, then on the water we should see it. So far I haven't processed the video yet, and I'm just doing this introduction right now, and I have a little bit more video to do today. But so far I've found some interesting observations. And one of them we're going to look at is that when we went to the CN Tower again, which I've done many times. I'm from Toronto. I'm American now. Well, I'm both. But I've been in the CN Tower many times in my life. I've lived in Toronto for half my life. So these things are an everyday occurrence. Being able to see the CN Tower from various distances, being up there, seeing so far away, different kinds of days, you can see further away. Now, what was the most significant thing about this video, I think, that you'll find, and I'll show a picture in the final cut of this video, where, you know, they say to us that 1.5 million people go through that CN Tower and see this sign. For how many years they've had that sign up there. It says on a visible day you can see up to 100 miles away. Now this is really significant because if there's a curvature of the earth and it's 8 inches or squared per mile, and there's a calculator on the website, on the internet, that says, you know, the numbers in there, putting in how high you are up, whether it's 0 feet, 1 foot, 6 feet, 8 feet, and then you put the distance and it will tell you the curve of the earth. So over a body of water, that should be pretty much you know, understood. You don't have to check the altitude because it's all going to be the same. Well, the problem is with Toronto, and the whole area is pretty flat. You know, we're going to look at Hamilton, because we start off in Hamilton and Burlington, 35 miles away. And, you know, it's only about, at the most, about 800 feet above the water level, the highest point in Hamilton. There's a little mountain. You can't really call it a mountain, but... So the point is, we're going to look at that and realize that the whole area around the CN Tower isn't very big, or isn't very mountainous, I should say. So it's relatively flat. You know, you got the Canadian Shield up more in the north, and you've got some little, I mean, they're not mountains by any means. I was out west, that's mountains. So the point is, if in the CN Tower it says you can see up to 100 miles away, then this is a problem. Now, I'm not really going to share which way I'm leaning towards in this thing. You might get the idea from what I'm saying. I'm not here to insult anybody. I'm here to just look at some facts. I'm able to learn from anybody under any circumstance, and I'm not afraid of the truth, one way or another, on anything. I've changed my beliefs radically many times in my life after realizing the facts. So, how is it that you could possibly see 1,000 feet up, relatively 1,200 feet above the water level of Lake Ontario? Because there's about 30 to 50 feet from the ground zero CN Tower, which we'll show in this video, to the water level. I thought it would be more, but it was actually pretty small. But on the standing deck that we're going to be looking out later on, the observation deck, the lower level, it's 1,115 feet, looking down through the glass to the ground. So, you know, we're about 1,200 feet above the water level. So how is it that we can see 100 miles away with really no mountain ranges or anything? How can we see 100 miles away according to that plaque when the curvature of the earth would be roughly 6,600 feet? Either there's something very wrong with the calculator that people are using, or the earth is much bigger if it is a curved area and when you can see 100 feet away. So that, I have no way of verifying the size of the earth right now. And I know, we all know that, well, maybe some of you don't know, that the maps have been wrong. The Peterson projection map, I think, was, they say, is more accurate rather than the standard maps that you see in books in the schools, which really showed Africa as smaller and Europe is bigger. You know, that was due to several reasons, supposedly. But the point is, what I'm saying is, I have no way to verify. You know, I've been over North America, I've been to Europe, I've been all over the United States and Canada, and you know, I've flown. I have a lot of experience flying far distances. I haven't been to a lot of places on this earth, so I don't know. I haven't been to Antarctica myself. It would be interesting, but millions of people have flown across the world, thousands daily, tens of thousands. So I haven't flown over this way at the Antarctica. Maybe it's bigger. I don't know. I don't really, you and I don't have really an easy way of verifying that. It's going to take several facts to consider this whole thing. That's why people call it a theory. Of course, you know, the standard governments of the big countries of this world all agree in their stated publications that the Earth is relatively 24,000 miles around. But is that the case? If that is, and it is round, not really like an oval. I mean, they say it's a slight oval, but that wouldn't affect really these calculations here. So we're going to look at the video that I produced. We're going to look at videos that other people have produced with these questions. You know, I see a curvature in the sense that I see a horizon. I bring this up about the sun. These things I don't know how to place. I've heard some of the my friends in that describe their understanding of things are pertaining to a flat Earth view. I don't understand it yet at this point. But what I'm saying is, if the horizon is measurable with something like a harbor on one of the big Great Lakes, I'll try Michigan next with this, Lake Michigan, and if we can see over 10 miles, it cut off at the rate that we're supposed to see it according to the curvature, then that's one thing. If we go even further back too and we don't see it consistently, but yet we do see it, there maybe is a third alternative here. Maybe there is not a dome necessarily, but maybe there is a bigger Earth. Now that would be something I haven't really heard people talk about. I haven't done a lot of research on this subject yet, but I am a scientist, and in other matters, more in electrical matters, and so I can appreciate you know, what's involved in researching something out like this. So what I'm going to say is I don't know at this point what those exact facts are. I didn't attempt to do exact precision measurements and get expensive cameras here, but what I'm trying to do is recommend this because I really haven't seen very many videos or people attempt to do this sort of thing on the water. I've seen a few videos that were closer, but I think we need to go back, you know, 10, 20 miles out where we can see still with our eyes and compare that with the camera, because there's apparently this question about whether cameras lenses are accurate because they're rounded or something like that. You know, it gets frustrating because the more and more you try and analyze a claim, it's unverifiable, and that's where it gets frustrating for me, that I don't believe things are unverifiable in that sense. But as soon as you start saying to me, my eyes aren't accurate, my senses aren't reliable, the things that we do in everyday life that we absolutely verify in numerous ways about our senses, and trying to impute the absolute certainty of our senses that to me, what can I do with a theory like that? It's not even verifiable. Now I want to say this because this is very important. I believe our senses are infallible. I don't believe that our judgment is infallible. We can make opinions about what we see. We can have assumptions. And that's where we see an object and we are deceived by that object by trickery or by mistakes because we make an assumption about the object that we're seeing. Now I did a little video about that with a Brain Games TV show where they were trying to show that, but then they exaggerated the whole thing and actually used lying, deception in their video to try and prove their point, which was ridiculous. Another subject. But my point is, we all trust our senses. We have nothing else but to trust our senses. But what we have to be careful with is the assumptions we make by what we see or hear. And it's not that we don't hear or see the objects, it's what we think they are based upon what we see and based upon our guessing inside. So that's very important with this when we're evaluating anything, because obviously people are making assumptions all the time. So one of the things I want to do is critique a video from a flat earther, not because he's a flat earther by any means, but I want to look at it because it's a very big mistake that he made. It's not a popular video or anything. When I went to go in, before I came here to Burlington, Hamilton area in Toronto for this visit, I wanted to look at any other videos that had already been done like this. So there was a video that you'll see the link to where it showed how this guy was in Hamilton, sort of in mid-Hamilton, maybe a little bit on the edge of Hamilton, and he's showing the Toronto skyline across the water, and he's saying, see, look, you can see the shoreline, you can see the whole CN Tower, therefore we shouldn't be able to see that. Well, what I did actually is I went to the shoreline of both Toronto shoreline, you'll see in this video, and I went to the Burlington Hamilton shoreline, and I filmed from there. Now of course my visibility was zero beyond probably about 20, well, about 20 miles, so I couldn't see it. And this is what he should have done, because what you'll see here and I'll show a better picture of this. Oh, you got so much reflection going on here. But anyway, what you'll see here, it's too reflective. I'll show a picture of it later on. Was at the park that this guy was at, it was up on a mountain. So he was at least maybe 800 feet above the water level, or 600, 800 feet above the water level. Well, if there's a curvature of the earth, right? It wasn't like he was here and Toronto was here, right? He was up here, and he could see everything over here because he was already looking down this angle. So people don't even understand that basic idea, whatever you want to call it, the basic angles, how this works. Now if he was at the shoreline, like I attempted to do, and saw the same view of Toronto that he shows in his video, that would be totally different, but he was way up in the air. So what I want to do is just show this. I mean the guy no harm by exposing that, but I want to show, hey, you really didn't get all your facts right here. You know, the other thing I mentioned, which somebody else has mentioned, is we're going to look at the Sky Dome. Now the Sky Dome is right beside the CN Tower. You can look down. We'll look down at it in this video when we're in the CN Tower there. And you can see there's a dome. Now the top of the dome is 282 feet, they say. And we're going to look at some pictures and video from the side of it to realize it really is tall. I'm not exaggerating that. Their description of that is verified by me, more or less. And you can go and visit anytime and see these things. Well, if you were on top of a dome that was really big like that, you know, a quarter mile wide or whatever, and you were to lay down on your stomach and look around the edges, it would actually look flat on all the way around. It wouldn't look round. Now if I stand on this, you know, on a ball, I can see the round edge because I'm the same size as it. But when some object that I'm standing on is so much bigger, and I look, the horizon looks, or the edge looks flat all the way around. So, you know, people argue this way when they look at a camera and they say, well, look, the horizon is flat. Well, it's because we're talking about something that's, you know, billions of times bigger than us. You know, we're on an object that's huge. We're at least millions of times beyond the edge of our view. So we're not going to see a curve because it's too big of an object, too big of a comparison. You know, it's just the law of perspective, as people want to call it, I guess. So that's something that I mentioned in this video as we're going along, and we're going to look at all these factors. But I want to show, I want to lay this out. This isn't done professionally. This is a layman's on a visit. I mean, I labored yesterday. I ran about 6 miles through 90-degree temperature here, and I worked hard for this video, so I hope you appreciate the work that I put into this. I spent money on doing this by going to the CN Tower and parking and all that stuff. So I did this for the good of everybody and for a curiosity, of course. And you know, I hope you can appreciate that. And I just want to give some objectivity to this whole thing. And oh, what I was getting at is I want to encourage somebody else to do this more professionally, to go visit the same places that I visited and take the same shots and do accurate measurements and then you know, post it. So this is a very easy way of verifying this and really, I think, settling some things with real facts. Now I will look at everything and evaluate myself and come to my own conclusions as I actually revisit everything and think about it all. But I think this should help people go to the same locations that I discovered were easy to verify. Some of the places that I wanted to go were private property that I couldn't get to, so it didn't work out. One of the places the last place that I went to yesterday was about, I think, 17 miles out. From the CN Tower, and I did get a good enough shot, and it was just on a very small beach in Mississauga. So, you know, if somebody wants to go there and verify that, that's fine. And I hope that this video allows for that. So let's take a visit to the CN Tower. And yeah, it says right here the height, 1,815 feet and 5 inches, or 0.5 inches, 553 meters, 0.3 meters high to the very tip. Let's go visit the CN Tower and figure out what we can find out about. Is the Earth curved at all? Is it curved over water? You know, there's a lot of questions, and we want to find out just what ways can we verify these things that we've all assumed one way or another, taken for granted. We want to verify one way or another. Oh, and what I want to say is, what's very important is, why has this whole thing come about to question whether the Earth is round? Is it startling facts that have just blown us away, that are totally inconsistent with a round globe Earth, curved Earth? What is it? Now, as far as I can see at this point in time, you have the NASA agency is a big part of this whole thing, and that is that a lot of people have brought out questioning photos by NASA. There was, you know, the classic picture of the Earth from outer space looking down, and there's some photoshopping done with some of the clouds, and you know, you can say that whole photo was faked, or part of it was. When you see cropping and evidence of that, then you can know that something has been changed. Okay? Now, if that's happened one time, it will make people question everything that an agency puts out. If it's happened several times over many years, then you question it more and more. If the whole moon landing was faked, then that means people will really question really anything they say. If you could grant that there was a fake moon landing, would that mean every shot the NASA put out was fake? Or merely should you just question it more? And that I leave you up to. And I would caution you not to be over skeptical. It's good to be critical, but skeptical is an attitude of disbelief in the face of real facts, or what should be believed by a credible, reasonable person. Now, the moon landing, I guess one of the latest objections to the moon landing is not the classical arguments about the lighting and various other things that have been said for years, the flag blowing in the wind, but actually photography. Now, I have done photography. I have studied some photography to understand this very fact. To get a picture-perfect photo takes a good 5 minutes minimum to set up for, and you can't just take picture-perfect photos on the fly without looking at a camera lens, focusing in, and getting that good shot. It can take an hour to set up for really good quality. So the big question right now, over the last few years, has been from photographers who have said those pictures were impossible to do under the circumstances. You know, the camera was on their chest. There was no viewfinder. There was no ability to focus in exactly as you wanted it. So the idea of them getting all those pictures over the time period that they had was actually impossible. Anybody in photography could actually verify that. So either the numbers are wrong and they had a whole lot more time to take pictures, or they did it in a studio, which I think they've admitted they did some shots in studios or something like that. Well, so that to me is almost a laughable matter, how you could have all these absolutely crystal clear perfect shots while they were trying to do all the functions that they were sent there to do, and literally take a shot, I think it was every 55 seconds, and still do all their tasks and not have any blurry shots. Everything was perfect. It's just, it doesn't add up. To the average person, they don't think about those things, but any photographer looking at the time frame, even if a photographer was there alone, like you got the White House photographer, the president's photographer, it's all he does, you know, boom, boom, boom. But you got guys who are scientists who are trying to supposedly look at verify all the procedures they had to do in order to take off again, in order to properly do the things that they were doing there. They weren't there to take pictures as their primary task. There was no guy who was there just to take pictures with a camera out here. It was on them. So I extend this argument longer than I probably should have, but to point out that some of these objections with the NASA presentations makes people question not only, you know, did people go to the moon, or but, you know, really the imagery around the world that we are getting from these satellite photos. You know, obviously this brings to mind the question of, are there other islands, you know, or whole masses of land that people are not aware of, and that the general population are being, you know, kept from seeing. I mean, I don't want to promote speculation, but these are the kinds of questions obviously people ask. You know, obviously there's a big concern amongst conspiracy theorists that there's more going on in Alaska, or not Alaska, the Antarctica in the south. Is the landmass bigger? If the world is bigger and that's maybe a bigger landmass, I don't know. I'm just saying these are the kinds of questions people are asking, and if things are faked, you know, it doesn't help those who are geared toward disbelieving things, or those who are, you know, inclined to believe the worst, or just concoct all sorts of fairy tales. You know, and the fact is, if we're being misled in some way, then, you know, the public ought to know. So I'm not trying to promote one way or another, but objectivity. I have no fear of what the answer is. I just want to know, I just want to help out in this matter, and that's what this video is about. So with a very long introduction, we'll go over the rest of the things that I've discovered yesterday, and then I will add some more footage of this Hamilton Park, that this other video that was shown, just to give you an idea of the elevation, that it was on a mountain, and to correct that misconception. So thank you again for watching this, and hopefully there can be some lively discussion about this, and I'd like to hear from everybody, really what they do. I hope you don't criticize me for where I'm at, because, you know, I'm relatively new at this discussion. I understand, I'm not new to understanding a little bit about photography, or I'm not new to conspiracy theories and you know, views on various matters, but this subject has only been a relatively recent popular belief system with the flat earth and whatever. It's relatively new, so bear with me in that. So thank you. Alright, here we are in Hamilton, just approaching Hamilton. And you can see the bridge that we're going to go on way over there. Now, zoom in on that bridge. Now this is far away. Okay, there's where we're going to be going out. There's kind of a view. There's that bridge. Now, a couple things to note. We're going to go to several locations here. We'll start off at over there, which is a couple miles towards where I'm parked almost. Then we're going to move along. I'm not sure if I'll do that first or second. Whether we go to the tower right now and come back. I want to get a good shot at least 10 miles away. So we'll look at the map. Oh, yeah, I want to show my GPS where we are right now. So where we are is we put in the CN Tower. We're in Burlington. You can see where my position is. I could have gone a little bit further out here, but I had to walk a long way. So like I said, what we're going to do is go back out maybe right here if we can see anything from there, but I'm not sure. Let's see. It may be, Toronto may be obstructed. We may be able to just see a little bit of Toronto from this point right here. It's probably a little too early to come. Maybe come out here or somewhere. We'll show on the map. There is another place. So we're going to stop at a couple of these places, right here, if we can get out there. And right here, and then we'll take some shots along the way out here, and then just before we get in, we'll go over here to Etobicoke, southern Etobicoke, and we'll get a shot across there as low as we can so that we can see, you know, how high up things are. And somebody else can finish this if it's not clear enough today to do. So one of the questions that I have for people who believe or don't believe in a flat earth, or there's that boat again, or who believe in a globe earth or some other earth, is about the sun. It seems to be a big question. So if the sun, behind this cloud right now, is the same size in the sky at noon, which I can't look at here, I can only look through my camera. If this sun is the same size at noon as it is at the setting of the sun, it doesn't change size or get smaller as it heads towards the horizon. How can you explain that with either or any of these theories about the Earth? In other words, some people say, many people say, that if it was flat Earth and it was a small sun, then how come it's not going to get smaller as it goes supposedly farther away? Considerably farther away if it's a small sun. How come in the horizon in the morning, which I missed, we'll try and get this evening, how can this sun stay the same size? How come it's very bright and doesn't dim out, as some people ask the question? How come if you can go to the highest mountain in the world, you can still have night? If you're on Mount Everest or something like that, and you look and it's dark there at night, how can the sun not give light? Is it that weak? How come we can't see it with telescopes? Just how come? I don't understand that particular position, explanation. How come the sun doesn't set on an angle? It always goes down. It doesn't fade out, it just sinks into the horizon. It's flat. The earth. Alright, I was at this rock right over there. I want to get a shot from both sides to show where I was. You can definitely see Toronto. We want to look back where we were. All right, we are at the Sky Dome here, and all right, here we are at the base of the CN Tower, and I'm going to show my kids what happens when you back up. It feels like the thing is falling on you. Now that's kind of like a law of perspective, I suppose, too. I don't know what it's called, but it's pretty neat to do when you're a kid.
North side of Toronto. Here you can view it from the front, the side, and you can look down at the two glass panels on the floor. We're going up to the lookout level today. That's 346 meters above the ground. We'll be there in 58 seconds, traveling at a speed of 22 kilometers or 15 miles an hour. Anyone have Sky Pod? Anyone have tickets for Sky Pod? When you're up here, if you'd like to eat when you're up in the tower, we do have the Horizons restaurant and the food kiosk up on the lookout level.
我不恐高，大哥，我恐高。谁不恐高啊？我真恐高。恐高怎么说呀？长得高的人就恐高。呵呵，那我也恐高。我耳朵好难受。张开嘴。
We're almost at the lookout level now. When you're ready.
All right, here we are in the CN Tower, looking out. Of course, you can see how much smog there is. Can't see very far. We want to go out here, first over here, to see the level. Actually, we're going to go down here shortly and see how high up we are. And then what we're going to do is drive out over here as close to the water as possible and see how high up or what buildings are in the way or whatever. And then we'll go try and get 15 miles out, see if there's a 150-foot drop. Now there might be a 100-foot of ground level here, so we have to consider that. But we can look at the dome. It's 282 feet. We can judge that. We can see it through all these buildings. So let's look at where we're going to be. somewhere around here. And then somewhere around there. So it's not focusing in on this camera. So then we can look at the sun again. See, it's the same size as before. Look, I see some sharks. 1,112 or 1,115 feet.
I'm so scared.
Remember, we were just standing underneath there looking back. Sam, you can't do it? Sophie, what do you think? Yeah.
I actually have smarts. I don't want to die falling off.
You don't think that glass is?
Yeah, it's only that thick. It's only that thick.
It's actually 2 pieces of plexiglass with an air pocket.
I died if I was standing on the bed.
Alright, we can see a little blurriness here through this net.
Probably that's why they put this thing there.
But you can see how tall some of these buildings are.
You really think someone's going to...
They're pretty high. I mean, they're getting close to this height, especially over here. This white building. Okay, so we're here at the water level. I'm 4 feet up, and we didn't really go that high. It's actually pretty close. We went down at least actually 20 or 30 feet down that road while I was walking, and we got 4 feet here. We probably stayed about pretty flat to the road over there, so we're no more than 50 feet in my estimate. Somebody probably verified that already, but Sophia. So, what were you gonna say?
If the earth was flat, I'd feel like I've been living on a piece of paper all my life.
Really? Why is that?
Because, well, I just believe that the earth isn't flat. Because if it was flat, the thought of just like living on a long, just basically a piece of paper.
So what's the difference between like a paper globe instead of a flat paper?
Well, I don't really know. It's just the thought of globe. You don't think of paper. A flat Earth, you think of paper with just 3D little 3D stickers on it.
Oh yeah. So you're saying that if it was flat, you think it was all just like pretend?
Yeah, that's how it feels to me.
Just kind of like a coloring book or something like that?
Yeah, pretty much.
What else do you have to say?
Nothing else really.
Was this an interesting adventure?
Kind of.
What about you, Sam?
Well, one thing that shows to me that I think the earth isn't flat is because when, say if you're going, before bed or in the morning, you can lay down on the ground and watch the sun set or it rise. And, well, this is for the sunset. You lay down on the ground, watch it set, you stand back up, and then you see it set again. So if the earth's flat, that wouldn't happen. It would have gone down.
Well, explain what you think about the sun in that respect.
Well, I think that if the sun is overhead at noon, and it's the same size as when it's setting, then how is the sun not being smaller as it goes away?
Yeah. But how is that about the horizon, what you were saying? Where you're lying on the ground and you see it set and then you stand up?
Yeah, and then I see it set again. I see it set twice.
So you can't comprehend how that could be on a flat Earth. So these are questions people need to answer, I suppose, right?
Okay, so we started off.
Okay, so we are here on the map here, Humber Bay. You can see this here, and you can see these various buildings here. And before I'll get up in a minute, but I just want to show you where I am. Pretty close to the water here. I am. Well, let's just get down here by the water. See, as we can get without falling in. So now we can at least see things pretty close to be able to see how far away that is. According to this map, because we are looking at right there, so there's quite a bit of, we're almost 10 miles away here. You can look on the map later on, but about 5 miles across the water here. You know, it's not going to be very much. So if we go way down here to the water level, there's the CN Tower. I'll get my camera wet. We don't really have any waves going on here. Anyway, we need to get farther out. But what I want to show is where I am. Right here, Humber Bay shores. Okay, I'm here at Royal York and Lake Shore or Harborfront or whatever it is, and I'm pretty close to the ground here. I'm about 2.5 feet above the ground. Let's probably bring this down here. All right, now I'm about 1 foot above the ground, or above the water at least. And there's Toronto. This is about, actually, I looked on the map and we're about 8 miles or so away. Maybe 9. So we're going to try and go to Mississauga next and get about 15 miles away. So you got Toronto Island, Center Island, and various other Does that show a curvature or not? Should I be seeing a curvature over this water? I mean, I'll try and get a little bit lower here, but I don't want to drop this thing. Now I'm a foot above the ground. All right, here I'm in Mississauga, at a certain park here, I think Leaside Park or something like that. I had to come down this little trail here. So I'm right between these two big, whatever you call them. And we can see Toronto here. So I'm standing up right now. So I'm 5.5 feet high, and I'm going to focus in. And you can see the Toronto Harbor. Now what I want to do, get really close to the ground, so we're going to go right here. We only have 1 foot rock here, so this should be sufficient. And I'm going to focus in. I can get the right angle here. We've got to get just the right angle here so we don't. There we go. Alright. Here's Toronto. So we're about 15-16 miles away. We'll look again on later on the maps. And you know, we can make out everything that we need to make out. Now, as I showed, those other buildings are pretty high up. It's 1,100 and let's just say almost 1,200 feet to the bottom of the platform. There. Does this represent a 150-foot drop to the base of the CN Tower? That's the big question. We can see the top there. We can scale it and figure it out. Have we lost 150 foot? So that's a good question. Appears to me, no. There is a curvature, no doubt, but I think it's less than what they're reporting. I mean, it's hard to tell from this picture just straight up without doing all the math, looking at all these things. It's not the clearest shot, but I think it's sufficient. We can scale it by looking at all the other buildings and the CN Tower itself. So I'm going to take another picture here. Well, I'm going to move up a little bit closer. Alright, here we are in Mountain Drive Park, or the other park that this guy shot this video from. We're on the Niagara Escarpment, taking some pictures, going up. We had to wind all the way around just to get all the way up this, to this elevation. We are either around 400 or 600 feet above the water level down there. I think it's 600 feet above sea level. We'll look at that later at the details. We are high up above the water. Now we are only a few miles from the water, and a good 5 miles maybe to the bridge where I took my first shots yesterday. Now unfortunately we can't see the same view of Toronto because it's so hot right now. It's 90 some degrees out here. But I want to show you where we are here on Google Earth. You can see this park here I've taken pictures of, and we'll look at it over there. And then I'll just expand this out. Oops. So you get a feel for where we are. We are in Hamilton. There's Hamilton. There's Burlington. So let's go over some details here. I'm going to try and see here. It's so bright that I want to be able to see my image here and talk to you while I cover up here with the towel. You can see this orange towel here in order to get it dark enough for me to see what I'm doing. So now this guy was claiming that it was a flat earth because he could stand up here and see Toronto in the distance. So first of all, let's look at the bridge. We can see the bridge from here. It's not too far away. Hold on, I gotta move the camera over a little bit. There's the bridge. I got some pictures of it. But you can see how hard it is to even see that bridge only about 5 miles away. So we were just up there, came around. So just left of the bridge, I was down yesterday. Where's my fan? Right about on the other side of the ramp there, at water level, trying to see if we could see anything. But we couldn't. Now what we could see was a little bit beyond the bridge. Right now you can still see a little bit beyond the bridge in this shot here, but it's so hot that it's hard to see. But what we want to do is look around. The other guy's video is acceptable. It's acceptable on YouTube, that video, except for the fact that he didn't really consider how high up he was. So if we are hundreds of feet in the air, then we would expect to see a further distance if there is a curve in the earth. If there isn't a curve in the earth, we would expect to see further as long as visibility wasn't impaired. And of course that is a problem. Yeah, I've got the smokestacks in the way of where Toronto would be, but there's no way we'd have been able to see it anyway with this mugginess. Now there is, to the left of that tallest smokestack there, you can see those black buildings, which I never really figured out where they were. But that is something to look at, because we looked at that from the ground level yesterday. Anyway, if you want to look around, that is facing more towards Niagara on the lake, and then Rochester would be farther out that direction, over lake. So what I just wanted to point out is in that video, it would be right in this direction that we'd be looking at Toronto. But since we are perhaps 600 feet in the air here, over top of the water level, then we would expect actually to see that. If you calculate the curvature of the Earth with the calculator that they use, then we can see pretty much what we would expect to see. Maybe a little bit less. Alright, here we are about a mile or so down the road on the Niagara Escarpment, still in Hamilton. Just in case I got the exact location wrong that this other video on YouTube was showing. It was somewhere up here on the Niagara Escarpment, and the map the mountain park is up here somewhere. So now you can see again the bridge, and beyond it some buildings in either Oakville, around Oakville, see those buildings faintly in the distance. No Toronto from this view because it's too cloudy, but it would be right about there. So again, I want to show how high up we are. Looking down at skyscrapers. So we are hundreds of feet in the air. Okay, I'm here on the edge of, well, I guess I'm still in Burlington. Camera down here. So I'm in Burlington here, out on this walkway here, and I want to show the coordinates here. Again, we're at the bridge. You can see beyond the bridge here, distant mountains. There's a building way up there. So that's what we were looking down on. And then the first day we started, we were right on this beach right here. Some dock, right? Or deck that was right over there somewhere. And that's where we started out yesterday in Burlington. Right, here's this video on YouTube again that I'm mentioning that we went to the same location today and looked at this from the Niagara Escarpment in Hamilton here, at least 360 feet above the water level of Toronto and of Hamilton, of Burlington, so forth. So it's called Flat Earth, the view from Hamilton Mountain to Toronto and beyond. And there is the website. So the first thing I want to notice, obviously, is we're looking down on top of buildings here. And also that he has just mentioned in the video that he was on Mountain Park Road. Well, it's actually Mountain Park Avenue, and this is exactly where we were. I was today. I took a picture here, and I also took the starting picture. It was right here. This is where we were located. And I showed Mountain Drive Park, some pictures there. I showed a sign picture there, one of the pictures over here somewhere else. Anyway, I want to look down at some of these apartment buildings. We're looking down at some of these buildings here that were very high, and one of them was a 20-story building. I got a picture of it, and I'll show that after I edit this video. But the point is, on Concession Street area right here, this whole, I had to drive up here and make several turns just to get up this hill because it was so high. So we're looking at, you know, a 20-story building being over 200 feet, and down here, which is obviously above the water level, and so that's important. Now we can go through this video and see some more details. You can see him looking down. So there's a fairly tall building there. And then he starts looking at Toronto. Well, it really isn't conclusive here that it is what he's talking about, because, as I said, if we look at it's very difficult to see from his picture the shoreline, but like I said, if we're high enough up here, then the curvature is going to be such that it's going to allow for us to see. So somewhere about here would be center point. You can't really tell because it's water. That's why we got to get down that shoreline and see it. So we got to wait for a day where we can see it clearer. And then, like I said, what we need to do is measure these buildings. You can see this building right here. As I said, in the tower, the antennas are almost as high as the observation tower. So with all these, we can do the calculations and see, you know, with a better camera and maybe a clearer day, we can measure the height from here to here and go downwards and get an idea how much is cut off, so forth. Or we can look at the shoreline and see what's cut off here, if anything. Now, once we're on the shoreline and we look at 30, let's go with it being 5 miles shorter, so let's do 26 miles away at a 1 foot height. So now we're at 409 feet. So if we were to go back here, we would be able to see noticeably cut off 400 feet. Or if we went a little bit higher up, like there was one picture somebody took, they didn't really say, they said it was 30 miles away, 360 feet. Boom. So that would mean we would be up here cutting off this section of the horizon. The horizon would be right there. We wouldn't see the shore. Now that's what we see in the other video of the guy, not as detailed as this, and it's cut off, which shows that there's a curvature. Now, like I said, we measure exactly from this point where I was. Let's see, I was over. Let's go back to, I mean, it was a little bit over on this side. Over here. So if we did the exact measurements and we had a really good camera, then we can figure this out. But these videos don't show that, really. So again, we can see from this guy's picture, his video I mean, that he has, well, this is actually a 16 story building right here, and you can see the top of the roof on an angle such that you're at least 100 or 160 feet above that. So we're talking about, you know, being up there 360 at least feet. That seems to be more than that. Alright, this guy further states in this video that he can see Niagara Falls. Of course, that's the title of this video. That he is 41 miles away from Niagara Falls. Now, again, these are still shots. And he's not shown for certain that he's in this location. For all I know, he could be way out there, halfway across the lake, taking a shot from a sailboat. I hate to question that, but we don't see any video here confirming the exact location. As I've shown in my video, actual markers with multiple cameras in the same place. So I looked up a few things here. He's looking at the I looked at his distance calculator, and sure enough, 67 kilometers is also 41 miles. Now, you would have to go across all this land, and nothing would have to be that high. I haven't confirmed that, but the height of the Skylon Tower, as it's called, is it is 775 feet, or 158 meters, 775 feet, yeah. So now, the problem I have with this again is, how high up is he really here? He's saying that he is in this location where I was actually yesterday, over here. Where are we? In Toronto. And he, let's see, he was on Royal York. Where am I? New Toronto, Royal York Road. Right here. He says that he was right there at a friend's house. Right here. But I don't see any evidence of that. I was right there. I showed this. I showed the street sign. I showed the shot of this apartment. For all I know, he could have been up in this building right here, really high. So I don't see that so far. And for all I know, he could have been halfway through across Lake Ontario and taken that shot. Again, it shows a horizon anyway, so I don't get the point. His point at the beginning of this video doesn't make any sense of this perspective. Hold on, let me get it right here. He's saying that, let's see. He's saying something. Hold on. Somewhere in here he's pointing out that your perspective changes this way. Well, I'm sorry, but it doesn't. Parallel lines may appear to intersect. They don't actually intersect. If you have a camera, you can see the vanishing point is the horizon line, unless your eyes can't see that far. Well, of course, if you have a camera, you can zoom in and see. You know, it's not that you just can't, it just disappears because it's so small. It actually goes out of sight, just like we saw in his video here. So I don't get his point. The horizon line doesn't change here as some kind of law of perspective. This doesn't get warped and get rounded or something like that. It's straightforward. It doesn't make any sense to me what they're saying. Maybe I failed to see it. I just don't get it. This perspective. So I'm going to continue watching these videos from the same guy, apparently. Good of All 72. Fellow Canadian here. Not doing a very convincing job of the math here. So. Alright, here we have another video of a guy in the same location that I was on the other side of the bridge, Hamilton Beach, which is on the other side of the big bridge that we looked at. I guess the Hamilton side, I was on the Burlington side, if that's where the dividing point is. Now, he shows in this video, first of all, he got some pictures from the lake view up here, which is a good 35 feet in the air, maybe 40 feet with him standing upright. But he said he went to the beach, first of all, to show his first pictures. And so this is the view that he has. You can see he is pretty close to the water there, probably a foot or two above the water. And you can see that definitely a few hundred feet at least is cut off. Now, he's about 26 miles out, not 32 or 35 as he was loosely saying there. And so, you know, if this is 750 feet, this does not look like it's half cut off, 400 feet there. So if we go to the Earth calculator, if he's 2 feet above the water, 26 miles away, he would have to cut off 392 feet. Now I can't tell for certain that he's at that location because he only has a picture and he could have been moved to somewhere else. On my video here, I'm showing you the continuity with the picture, so it's not absolutely certain that this is a fair picture here. We'll look at the rest of his video and see. But if now we were at 1 foot, let's look at that. We'd need 409 feet cut off from there. So at this point, we'll wait and to see the rest of his video.